Well, hello again. It is very good to have you back as usual. Today we're going to start this video out with something a little different. I have received an email, or a Gmail I guess, from one of our good subscribers, TJet737. His name is Tony, and he's a pilot for Delta Airlines. So I guess TJet stands for Twin Jet. And the 737, of course, is the aircraft. And in his Gmail, he said, "Today, while flying from Atlanta to San Francisco, I took a picture of Conway, Arkansas from 32,000 feet. Now, normally, it seems that every time I fly over Little Rock, it's under cloud cover. Well, maybe he ought to fly over in August, though." Anyway, he says, "But not today," which was Monday, January the 15th. "I know it's not the best of a picture, but you can obviously see Conway and Lake Conway. I was thinking to myself as I was flying over, somewhere down there's a fella working away in his jukebox." He put LOL, "Take care, John. His name is Tony." Well, he was right. On that particular day, the 15th of January, I was down here in the shop here working on the old jukebox, on the Tormat, matter of fact, and putting together the previous video to this. So I'll tell you what, he mentioned Lake Conway here. For all of you who may not know, Lake Conway is the largest man-made Fish and Game Commission lake in the entire United States. It's 8 miles long. It has a shoreline of 52 miles. That's a man-made lake. Isn't that amazing? Anyway, I really appreciate him contacting me, and I'm going to show you the photograph of Conway. Now, Lake Conway will be down in the right-hand lower portion of the picture. If you squint and look real hard, you can see me. Okay, try hard. I'm in there. Anyway, I think what we'll do is, while you're watching the picture or looking for me, we'll give old Tony a nice round of applause. And of course, last time I forgot to do something. I said when I removed the top hat diode that I would, talk about it a little bit more. And I overlooked it and forgot to do it. And of course, one of our subscribers, he had to remind me, "Oh, you're going to talk about the top hat diode." Look, guys, there's nothing that couldn't have been looked up on the internet. Just Google top hat diode. You learned everything you needed to know. But I said I would do it, and I didn't. So that's the point. The reason it's called a top hat diode, I guess you can see, it looks like a little top hat. And it's just a standard diode. Originally they were, I guess, germanium, and then later on let me see if I can find my pencil here. Later on they became, silicon diodes. Generally speaking, almost in every case, the brim of the hat is the negative. This is the positive here. Negative, positive. Now later on, there were some that came out that had it reversed. I don't know why. The 1N2720, I believe it was, had this end as the negative and the brim of the hat as the positive. It's a silver diode. Looks just like it, though. Well, until you find out differently and test it, you really don't know. So, and it's usually there's some printing on the side of the diode that points to the cathode, or it just shows you which end is the cathode, which is the anode. Unfortunately, this little thing has nothing of the kind on it. There's no markings at all. It's all covered with crap and everything from years of sitting in there. I don't know why. I've looked at it really close. I can't find a thing on it. Nowhere. So we're going to have to find out ourselves, aren't we? Now, I have two ways of testing this. I can use my multimeter, or I can use that little green screen testing device. Let's use the multimeter today, because most of you may not have this. Where is it? Most of you may not have one of these little things. Eventually, everybody's going to have one of these. It's just so good, But we'll go ahead and use the multimeter. And the first thing we're going to do is we're going to set the multimeter to the diode setting. Let me get a little focus here. To the diode setting, and right here. So let's get that done. All right. Now we'll go ahead and I've got 8 gator leads connected to my multimeter leads to make life a little easier. Let's find out. Let's go ahead and hook the let's hook the positive to the anode, which is what the anode is or supposed to be. Now let's go ahead and hook the negative to the negative side over here. Let's see what happens. Oh, we get us a nice little reading. How about that? I'll disconnect the positive. Now I'll reconnect the positive. Cool. Now let's go ahead and reverse the leads. I'll put the positive on the negative and the negative on the positive. We should get nothing, because a diode is a one-way valve, folks. It's a check valve. It only allows current to flow in one direction. Here we go. It's hooked up. I have it reversed biased, this is called. When you forward bias it, you know, positive, positive, negative, negative, you get a reading. When you reverse bias it, you get nothing. That's why it's a one-way valve. It's a check valve. It only allows current to flow in one direction. The next little thing to discuss as a result of questions from the last video was this. I have a second full-wave bridge rectifier here. And the question was, and it's a very good question. The question was, how did you know which one to pick? I mean, how did you know, how do you do that? Well, these things are rated in amperage and voltage levels, okay? And I talked it over with Brendan and everything. He said this is a 30-volt winding here. Probably no more than an amp will ever go through this full-wave bridge rectifier. So we decided, well, we'll try to find a 3 or a 4 amp rated at a higher voltage, maybe, 100 volts, 150 volts or something like that. So I went on eBay and I looked. You couldn't find anything. Either the prices were too high, or they wanted to sell you 10,000 of them, or the value itself wasn't there, the way we wanted it. So after a while, I just got fed up, and I wrote back Brendan. I said, "We're biting the bullet on this one, buddy. I bought this one here, 15 amp, rated at 600 volts." It was only like $2.50. I wasn't going to complain. I got 2 of them. So for the same price, I think it's $2.50 or $3, something like that. So yeah, overkill, you bet. You all know, if you've watched my videos for a certain amount of time, I'm a big fan of overkill. It would take an awful lot of stuff to burn, an awful lot of current to burn out a 15 amp full wave bridge rectifier, okay? Someone also wanted to know what the difference between this rectifier was and a typical, he said, a typical rectifier in an old radio. Well, I'll tell you the same answer in case you didn't catch my answer in the comment section. If it's a tube radio, then the rectifier is a tube rectifier, whether it be half wave or full wave. This is not a tube. It's solid state. That's the difference. You get them rated at various amperages and various voltages. If you really don't know, go for the gusto for $3. Who cares, One more thing Brendan wanted me to mention about these solid state full wave bridge rectifiers. They do get warm, okay? They are an item that does get warm. Now I have mine mounted here like this. It's 15 amps and there's not even anywhere near that much current going through it, so it won't get that warm. But some of them get pretty hot, especially if you're running it near the value you need. For instance, if you need a 3 amp and you buy a 4 amp bridge rectifier, it's going to run pretty hot. So the best way to mount this, and that's why the hole is in the center here, the best way to mount this would be to mount it, I'm generally speaking, in a case like mine it's no big deal, but generally speaking you should mount it either to the chassis like that with a screw, or over here to the side of the chassis with a screw, and bend the legs straight up, at 90 degrees. So you can mount it like this out of the way. I could have mounted it here, lots of room over here, but I could put your, and use a heat sink compound on the back. Or you could just buy a regular, a heat sink. Put it on the heat sink, bend your legs up, straight up, and then put the heat sink on the chassis. Because they do get hot, and you want to dissipate as much heat as possible. Otherwise, it burns out, okay? Inside our little pulse amplifier here is a black capacitor. It's rated at, it's a 0.003 microfarad at 1,000 volts. Well, you know, I could probably test it out and it might read 0.003, but you know, I can't apply 1,000 volts to that thing, or 500 or 600 or 700 to see if it would break down or whatever. I just don't have that capability. So what do? Well, we could leave it. It's probably good, and it probably is. I don't, you know, but this thing is a very old jukebox. Goes back to the 60s. Do we want to leave it in there? Not me. You can leave it in there if you want on your jukebox, not me, because I have a new one right here. Now this is 0.003. This is 0.0033. I don't have an exact 0.03 rated at 1,000 volts. Matter of fact, I don't even have one rated at 1,000 volts, because mine is rated at 3,000 volts. Yes, we will take this one, clip this one out, put this one in its place, and I'll be able to sleep better at night. We are getting ready to test the coils on this thing. Now the coils I'm talking about, these are these little brown things. As I said, these are 16 microhenry, and the other two, the smaller ones, are 11 microhenry and 11 microhenry. Now we could test each one of these individually, which is no problem. There's only 4 of them, but if you had a radio that had a pile of these things, you want to try to figure out a way to maybe check more than one at the same time. Well, let's go to our schematic and see if we can do that. Here is our assembly right here, and here's our coils. We have a coil. We have 1, 2, 3, 4 coils, plus the primary and secondary of that little black transformer. Now, if I hook one of my leads to the center of J510, now this is J510 right here, and the center is that hole. Okay, it says J510 right there. So if I hook my multimeter to that center post, where you can see there's a coil already soldered up there. If I hook my black lead there, and we're now connected there. Come on, baby, focus. Okay, there we go. If I connect my other lead to ground, which is right here, I will be able to check 1 coil, 2 coils in series, come across down through the primary of that transformer on down to ground. So I should be able to put my other lead right there on the little pulse amplifier chassis and get a reading on my meter, and it'll mean all, let me see, that would be 1, 2, 3 of those coils are good with 1 whack. Here we go. I'm just going to touch it right here to the chassis, anywhere, any metal part. Look at there. Look at there. We are on the 200 ohm scale. We're reading, oh, right now we're getting some capacitor charging, but you see that there is some continuity there, okay? Now we can go back and test each one separately. Just put our, you know, probe on one side and then the other. Come on, boy, this camera has a tough time with white stuff. Put a meter lead there, and it'll test this one. Put a meter lead there, and it'll test this one, and a meter lead across here. Now, one thing about this little transformer, you've got 2 leads on coming out of one. Let me see here. This is important to take note. Now, you may run into this at some time. It may be a different kind of transformer. I don't know, but it'll be somewhat the same. You see how we've got 2 leads down in there? I want you to see we have 2 leads coming out of this end, and 2 leads right down in there coming out of this end, okay? Now, the primary is not measured across these leads, and the secondary is not measured across these leads. It's measured lengthways from one on this side to the other one on this side. Now, this would be number 3. You can see it. If we tip it up, you will see number 4, okay? Directly across from the 3 is the 4. Now, if we look on the schematic, you'll see that 3 and 4, okay, through that coil right there. Well, I'm happy to report that all the resistors tested out good. The coils tested good. Even the capacitor, this little capacitor right here, tested good. And this one tested good, but we're still going to change them out. However, there are a couple of problems. right here, this solder joint, I'll give you a little close-up on there. This solder joint is really bad. When you see something like that, now this has not been changed out. This is actually factory, believe it or not, but look how poor that is. We're going to extract all that solder there and do a better job. The other end up here, you can see is factory. So that's all coming off. We're going to take care of that. Plus there's one other thing, this insulator, this heat shrink, or just an insulator wire, I guess. On this end of this there's a resistor right here, and the insulation goes around to protect it from the chassis. And you'll see it's pretty rough looking. It's even got some corrosion, that greenish corrosion. We're going to when we unsolder the capacitor, we'll be able to unsolder the resistor and get rid of that, clean it up with alcohol and everything, put a nice new piece of heat shrink there. And once we're done changing this capacitor, fixing the things I just mentioned, and getting rid of this black capacitor, once that's all done, we'll button her back up and we'll be good to go. I've decided that the best way to remove this solder on this terminal right here is not to use a standard, you know, plunger solder sucker, that type of thing. It would cause me to have to hold it and maybe damage something down in there, moving it around back and forth. So I've decided to go ahead and use my Hakko FR300 instead. It's perfect for the job. It'll fit right down in there. I had to move a few wires out of the way, but once I get down in there, I can extract it all off of that terminal, and then I don't have to remove the wires. All I have to do is extract the solder and then re-solder it. That's it, guys. The new capacitor's in, and this new capacitor. We fixed up our solder joint down here, so she looks really nice now, nice and shiny the way it's supposed to be. And we have the yellow lines there are the two new heat shrink lines. I'll tell you what, underneath that resistor, that black resistor insulator that was on there, oh, the whole thing was just corroded from one end to the other. Fortunately, we caught it in time. I think it might have happened as a result of the flood, if I'm not mistaken. It was able to wash all that green crap off. We were right down to the nice shiny metal and we got done. Except for the very tip. I had to kind of sand it a little bit so I could get a good solder joint right there. But other than that, we're done. I'm going to go ahead and button her back up, and we'll call this one quits, and then we'll yank this baby out of here. I think what I'm going to do is call it a day for now. I do have the add, subtract, play relay set up out. And as you can see, there's quite a bit of rust on the bottom. Well, besides, wifey wants me to make some pork curry and rice tonight, and I've got a hankering for some of that myself. I can't wait to get in there and get the old rice pot cooking. But anyway, we have a lot of rust here. There's only two screws that holds this thing in, right here and right there in opposite corners, and they go through these bushings. There's one here and one underneath down there, opposite corners. A lot of rust there also. So it looks like the old navel jelly and Q-tip trick is the only way to salvage this mess. This is pretty nasty, and I don't want to take any of this apart. Now, that would be kind of dumb, you know. I don't mind taking things apart, but this thing here, I don't know how it functions. I don't know how it works, and I really don't care how it works. I do know the coils are good, and that's all I need to know. And the capacitors are good, and or at least they look good, okay? Their disc caps are nice and in good shape. When I tried to test them, all I got was inductor readings. Now you know why, because these are connected to each side of the inductors, or the coils inside of the solenoids, and I was reading the inductance inside the solenoid coils, or of the solenoid coils. Anyway, we're going to have to really do some heavy cleaning. This stuff works pretty good, but not like I would like it. It's just, it works good. It goes in and out, but one is dependent upon the other. If I can get this stupid thing to function. There we go. One is dependent upon the other, and they are a little bit stiff. So we're going to take this brush, and we're going to get some lacquer thinner. This is after we do some derusting, which is probably going to take a day or two at least. And then we're going to scrub the, you know what, out of this thing with lacquer thinner and try to get it functional. Maybe a little bit of oil down in here would help a lot. to get this thing moving. This is just nothing but a mechanical setup here, all driven by these wires to these solenoids. Alright, time for me to head to the house. It is the next day. I decided to just stay in the house yesterday. It just was so cold. And I've got some lacquer thinner in this old paint can top right here. And we'll soon be putting this on that rusty area that I showed you underneath our little play and add subtract setup here. I'm just going to go ahead and really work this baby over between the contacts and everything with lacquer thinner. I'm going to give it as best a clean job as I can. So all I'm doing is I'm just smearing that stuff on, and I am giving it, like I said, a lot of this stuff, for crying out loud, is on there like epoxy. I don't know how that happened, but it sure is. It's going to take me at least 5 more minutes to get this stuff cleaned real good. I'll come back when it is, or as best I can get it. Well, the entire mechanism is working okay, nice and loose now. It goes back, really springs good, except for 2 things. This little job right here, this little wing job right here, it's supposed to go this way. This one does okay, but it doesn't want to go back. I think a little oil will help that. See, she's supposed to spring back because there's a spring on the down in there. Now this one over here is jammed tight. It will not move hardly at all. I have really had a tough time with it. I hate to tear these things apart. I can get it to move if I force it, but see, it won't even leave the air. I can get it to move if I force it, but she's just flat stuck. I've used cleaner, and I think it's just a bunch of caked on nasty grease. And I'll tell you what, before it's over, I'm afraid I'm going to have to release this E-clip right here. Get this thing up off that shaft. I hate to do that because that spring is wrapped around and around that thing I don't know how many times. Man, oh man, there's a certain amount of time, so you get that certain amount of tension. So, I don't know, it goes around and around, comes around, hooks here. Oh, this is going to be fun. I got to do something though. I can't just let it stay like that. Well, I had to do what I didn't want to do. I took out this E-clip here. I took it off of here, but I didn't remove the entire hub from the shaft. I just raised it up as far as it would go, sprayed it down underneath with some contact cleaner, worked it over with the brush and the lacquer thinner, and I'm getting ready to put it back. And then we'll probably drop a little oil down in the hole before I do. Let me see, I'll just let you watch me do the whole thing. What the heck? If I can get the top off the oil, that is. Let's just put a little drop of oil down in there and let it sit for a second. There we go. That's all I need. What this is 3-in-1 motor oil. A little thicker than what we should be using, but I'll tell you what, it does the job. Let's go ahead and shove it on down in now and see what happens. Will this thing go back and forth? I'm going to raise it back up a couple of times. Let that oil work its way down in there. Push it back down. If this works, I'll do the same thing over here. If not, I may have to work on it a little bit more until she does get done. Oh, she's working a lot better now. Still should be a lot freer than that. Okay, I'm happy with that for now. I'm going to go ahead and keep cleaning. I want it to just flip right back, flip right back. Maybe the more I work it, the better it will. We'll see. Alright, let me show you what I'm talking about. That's what I'm talking about. See how she's flipping back? Now she's working the way she's supposed to work. This one here just goes over and stays. I think we have those 2 problems solved. This one is flipping good, real good, nice and easy. Same over here. This one's flipping real good. Now this thing here, I'm going to have to take off this E-clip, raise this up, and try to do a little bit with that too. It's working okay, but I think it needs a little bit of oil. Also, right here, I'm just going to take the clip off, raise it up a little bit, get some oil work down in there. It's just not loose enough for me. Well, now that everything is loose as a goose and cleaned up and oiled, I can see how this thing functions. I couldn't figure it out before because none of these gears would flip and flop around like they're supposed to. They were just stuck in one position. I said, what is going on here, Anyway, this is the way it works. But first I have to show you one other thing. It works in conjunction, from what I can figure out. It works in conjunction with the reverse switch on the Select-O-Matic mechanism. Now this is your reverse switch down here. This baby, when it gets to the end, sends a signal down here, and it apparently activates this solenoid first. And when it gets to the other end and it activates it a second time, I guess it's this one here. I'm not exactly certain which one gets it first, but I'm pretty sure that reverse switch you just saw operates this thing to get that carriage to go 2 times to the left, 2 times to the right. Now I'll show you what I'm talking about. Let me get a little bit closer here. I hope it doesn't get too blurry. But I'm almost certain this is the first solenoid that gets the pulse, because when you move it down, watch what happens to these teeth, and listen to the clicks. You should hear 2. Isn't that cool? And I think that's the way it works. And then when it's finally done with the 2 movements of the carriage to the right and to the left, this one here, I think, gets the next pulse and resets everything like that. So I think that's the way she works. If not, well, I'm close enough. As long as everything works, that's all I care about. All right, we're going to go ahead and you don't need to see how I derust it. I'm just going to take the Q-tips and, you know, the navel jelly and spend the next day or 2 derusting it, and I'll show you the results of the derust in the next video. But there is one more thing I want to accomplish before I close out this video. It involves getting the amplifier back on the bench. Well, as they say, there's no rest for the weary. Here's our amplifier again, and what I did was I took a wire from the 2 33 microfarad electrolytics that I had, and I soldered it onto the leads here, and I wrapped it on around, and I grounded it right there. And I used a nut and a bolt and a star washer. Yes, there is a star washer under there. I would never ground anything without a star washer, an external star washer, that is. And so I soldered it there, and there were some out there that said, no, I question. Now I love this one. I question you putting that there like that, but I suppose it'll work, you know. Hey guys, these things are a dime a dozen in lots of radios I've worked on. Matter of fact, there's some right here in this chassis. I'll show you one right now. See all this stuff here, all soldered to that tab? See where it's grounded to this screw and nut right there? Same. It would work fine for many years to come. But soldering it directly to the chassis is probably a ground that will last a lot longer than you and I. However, since 1961, that thing's been grounded there without any problem. How many years is that, Anyway, what we're going to do is I'm going to go ahead and unsolder this. I'm going to find a place on the chassis that I can go ahead and ground it to the chassis. There's a little tab sticking up somewhere. I may have to remove this wire and put a longer one on. I'll show you what it looks like when I get done, and then everybody can relax, okay? The new ground wire is in. I decided to, actually it was the only way I could go. Now there were other places I could have soldered it. Right here, this is a riveted on piece of metal, which is pretty good also for a ground. But I decided to make everybody happy and come on around like this. It was a long road, but we soldered it onto that tab right there sticking up out of the chassis. So that should make everybody just really, really happy for the upcoming weekend. Until next time, this is John.